The crab freezes inside its shell, antennae flicking a warning no one hears. Above it, 8 arms ripple through the darkness, each one tasting the water with 1,000 chemical mouths. The first thing you need to understand about an octopus is that it does not eat the way you eat. You use a mouth, a set of teeth, a tongue that knows texture and temperature. An octopus uses its skin. It tastes through its suckers. Every single sucker is a tongue dipped in acid and curiosity. When an octopus touches something, it is not just feeling it. It is tasting chemistry, reading pressure, measuring the exact coordinates of prey in 3 dimensions. And what it chooses to eat is not a matter of preference. It is a matter of survival, written into a nervous system that works nothing like yours. The 2021 review in Molluscan Studies confirms what field researchers have watched for decades. The octopus is a carnivore, pure and direct. It does not nibble seaweed. It does not graze on plankton. It hunts. And its menu is mostly small crustaceans, bivalves, and gastropods. Crabs, clams, whelks, shrimp. The familiar creatures of the reef floor, the ones that scuttle and clamp and hide. But here is the part that changes everything. BBC Earth describes the octopus as an opportunistic hunter, and that word does not mean what you think. It does not mean lazy. It means the octopus reads its environment like a crime scene. Every crack in the coral, every shift in the current, every tremor in the sand tells it what is available, and it adjusts instantly. You just watch the octopus scan its surroundings like a detective reading a crime scene. If that kind of sensory intelligence makes you want to understand more about how animals see the world, subscribe to keep uncovering these hidden nervous systems. And drop a comment with the animal whose behavior has always puzzled you. I want to know which creature you suspect is reading the world in a way you haven't caught yet. Leta, Hymovici, and Mather reported in 2009 that this foraging strategy is time minimizing. The octopus does not wander. It calculates. It chooses the prey that gives the most energy for the least risk. That is why small crustaceans top the list. They are everywhere. They are easy to crack, and they do not fight back the way a fish can. But when a fish is within reach, the octopus takes it. When a bird dips too close to the surface, the octopus pulls it under. When a newborn turtle scrambles toward the ocean, the octopus intercepts. The 8 arms are not just tools. They are a traveling nervous system that has already decided what to eat before the brain in the center has caught up to the thought. Now here is where it gets strange. The octopus does not have a single brain processing its hunger. It has 8 auxiliary brains, 1 in each arm, and every one of them is tasting the world independently. The arm that finds a crab does not ask permission. It grabs, it paralyzes, it delivers. The central brain only gets the news after the meal has already begun. That means the octopus is not a single eater. It is a committee, and sometimes an arm disagrees with the others. Field observations show octopuses occasionally reaching for prey with one arm while another arm pulls away. It looks like hesitation. It might be a negotiation between nervous systems that do not fully trust each other. The stable isotope studies mentioned in the 2021 Molluscan Review add another layer. By measuring chemical traces in octopus tissue, researchers can map what the animal actually ate over weeks, not just what it preferred in a tank. And the data show something surprising. The diet shifts dramatically between habitats, between seasons, between individual octopuses living a few meters apart. An octopus on a rocky reef eats mostly crabs and clams. An octopus on a sandy flat hunts shrimp and small fish. An octopus in a seagrass meadow pulls snails from their shells. The species is the same. The nervous system is the same. But the environment rewrites the menu. This brings us to the myth. You have probably heard that octopuses are picky eaters, that they specialize on one type of prey and reject everything else. It sounds reasonable. An animal with a sophisticated brain might develop refined tastes, but the evidence says otherwise. BBC Earth calls them opportunistic, and the 2021 review confirms that their diet is flexible precisely because their nervous system evolved for uncertainty. So, the myth of the picky octopus is just that, a myth. If you are the kind of person who wants to go beyond surface-level animal stories and see the real evidence, subscribe to stay with this investigation. And in the comments, share what assumption you have caught yourself making about an animal. I am curious which false belief you are ready to leave behind. The octopus does not know what it will find tonight. It knows how to find whatever is there. The arms taste the water, and the brain updates the plan. That is not pickiness. That is planetary-level adaptability in a creature that lives only 1 to 2 years. And now the hard part, the part that rewires how you see this animal. If the octopus can shift its entire diet based on what the water tells it, then its eating behavior is not a habit, it is a conversation. The octopus negotiates every meal with the environment in real time. The stomach is never the decider, the skin is. But wait, there is a deeper tension here that the facts do not resolve. The octopus is a predator that evolved in a world of prey that evolved to avoid it. Crabs have shells, clams have locks, fish have speed. Every meal is an arms race, and the octopus wins most of the time because it thinks like the prey before the prey thinks of itself. The arms already know where the crab will run. The suckers already taste the panic chemicals before the crab has finished secreting them. The octopus does not chase, it predicts. And when it predicts wrong, it adapts its prediction for the next hunt. That is not hunting, that is learning through ingestion. So what does the octopus actually eat? The short answer is whatever it can reach. The long answer changes everything. The octopus eats the story its environment tells it, and the environment tells a different story every night. You have been thinking about the octopus as a creature with a preference, a creature that chooses one food over another, the way you choose a meal. But the octopus does not choose. It reads, it tastes, it calculates. And by the time you have finished this sentence, it has already moved on to something you will never see. The arms remember the taste of every crab they ever held. The suckers keep chemical records of every shell they pried open. The octopus does not forget a meal. It carries the memory in its skin until the skin itself dies. And that is the real answer. The octopus does not eat what it wants. It eats what the ocean gave it the curiosity to find. The rest of the world has been telling you that intelligence separates predators from prey. But the octopus does not use intelligence to hunt. It uses attention, a kind of attention you have never learned to pay. Tonight, when you close your eyes, the octopus is out there. Its arms are reaching. Its skin is tasting. And in a crevice somewhere between the reef and the dark, it finds something alive and decides in a fraction of a second whether to take it. The decision is not made in a brain. It is made in 8 separate conversations happening at once. And the prey does not know it was ever a calculus until the pressure closes around its shell. The question was what the octopus eats. The answer is whatever it can find. But behind that answer is a larger one. The octopus eats because it has to, but it hunts because it can. And those are not the same thing. Not for the crab, not for the clam, not for you, sitting there, realizing that the creature you thought you understood has been reading the world in a way your own nervous system cannot. You now stand at the edge of that gap, knowing what the octopus eats, but recognizing you will never taste the world the way it does. If that kind of honest boundary between knowledge and experience feels important to you, subscribe before you leave, because the next creature we examine will challenge your assumptions in a different way. And in the comments, tell me one thing you wish you could sense, but cannot. A chemical, a frequency, a flavor the octopus knows, and you do not. That is the thread left open. You now know what the octopus eats. You will never know how it feels to make that decision. And that gap between knowing and sensing might be the only honest answer there is. A nervous system that tastes before it thinks does not choose meals. It responds to opportunities, and every opportunity is a chemical story written in the water. That is why the octopus survives in environments where specialized predators starve. It does not depend on one prey species. It depends on the act of paying attention. And that attention comes at a cost. The octopus lives fast and dies young. 1 to 2 years is all the time it has to learn every taste, every texture, every tremor that signals a meal. After the eggs are laid and the female starves herself guarding them, the octopus body begins to fall apart. Its skin forgets how to taste. Its arms stop negotiating. The predator that read the world through its suckers becomes a husk drifting in the current. But before that end, the octopus lives a life of total sensory engagement. Every meal is a decision made in 8 places at once, a consensus built from chemical data the human brain cannot process. The crab does not know it was tracked. The fish does not feel the prediction before the arm arrives. And you, sitting in your chair, will never taste the water the way the octopus does. The answer to the question is simple. Octopuses eat crabs, clams, shrimp, fish, snails, and anything else small enough to be caught and soft enough to be torn. But the truth behind the answer is something else entirely. The octopus eats the world one chemical at a time, and the world never knows it was read until the reading is over.